Yeah, welcome to Python Live, everybody. Obviously, glad to see so many familiar faces from, I suppose, everything that I deal with. Obviously, quick introduction. I'm Sam, one of the senior consultants here over at Amicus. Obviously, I'm joined very excitedly by Jose, who will be delivering the talk tonight. Obviously, it'll be a quick talk. It'll be a talk around about half an hour, 45 minutes. Please feel free to use the Q&A session or the Q&A section on this on our platform to ask as many questions as you want. Jose is going to be answering in and out as and when, and then he's going to ask you a few questions as well. So feel free to join in as much as you want to, and we'll go from there. So yeah, I suppose enough from me, and please, yeah, take it away, Jose.
Let me start showing first of all. All right, and just to confirm, you can see the PowerPoint, right?
Yeah, we can see the PowerPoint. I can at least. Can everyone else just say yes in the chat if you can, or if anyone's struggling at all?
Okay, and just to make sure it's all working, if I change the view, can you see my browser now?
Yeah, we can see your browser.
Okay, so all right, thank you everyone for coming. Thank you to Sam for organizing the event very kindly, and for Amicus Recruitment for hosting the event. And I'm very excited to give this talk because I think API security is very important, and there are many ways our APIs can go wrong from a security point of view. So I'm trying to do as much as I can, doing events, writing about this, sharing tips on LinkedIn and Twitter to help and raise awareness about API security, how our APIs can go wrong, and what we can do to improve the security of our APIs. And also, I'm working on an open source API security testing tool. It's called Fensa, and I'm going to present that tool here. What I want with this talk, it is really targeted at API developers and API designers. And what I want you to take away from here is some learnings about how our APIs can go wrong from a security point of view, the kind of vector attacks we can have in our APIs, and what we can do when we are writing our code, when we are designing the API, what we can do at any time to make sure that those things don't go wrong and our APIs are as secure as possible. So before getting started, a little bit about myself. My name is Jose, as you know. I'm a consultant, instructor, and an author based in London. And I'm the author of Microservice APIs, this book over here. And this book is kind of a one-stop book where you can, it tells you everything you know to build robust and high-quality microservices and APIs with Python. And I'm also the founder of microapis.io. This is the company that I use to offer my consulting services. And so if you're working with APIs or microservices and with Python, I would love to talk with you. If you are interested in my content and want to connect with me, I would love that as well. So you can follow my content on Twitter. You can check out my work in GitHub. I also have a newsletter in Substack under Macro APIs, and I'm trying to get it active. Not happening yet, but I'm trying to get it more active. And really where I'm more active is on LinkedIn. So if you want to connect with me and follow my content there, I'll really love that. I'm running a giveaway here. So 3 ebook copies, microservice APIs, and 15 free signups for my online course, Build APIs with Python. If you want to enter the giveaway, grab this URL here or scan this QR code. I'm going to put the same slide at the presentation. So don't worry if you can't get those details now. And I aim to announce the winners on LinkedIn on tomorrow or after tomorrow as soon as I can. Now, so what I'm going to talk about is API security and how we can how we can use testing to discover API vulnerabilities in our APIs and to help us improve the security of our APIs. And perhaps a little bit of context first about why I want to talk about this. And the reason is because I do a lot of work with clients designing and building APIs. And a constant source of friction here is security. So there are a lot of ways APIs can go wrong. And especially when I check out a legacy API implementation, something from, let's say, 6 years ago or something like that, when we were not so aware about the ways APIs can be hacked or can be hijacked, I encounter a lot of issues from a security point of view. And so what I've been trying to do over the past couple of years is to grow awareness about API security risks and to help people to improve the security of their APIs. So that's the reason why I'm doing things like this, why I'm also working on Fensa to give a tool that people can use for free, all kinds of companies, and get a baseline about the security of their APIs. And that's why I'm also excited about doing this webinar, because it helps me share these insights and this knowledge with you. And hopefully you can learn at least a couple of actionable insights here that you can start applying straight away in your job. The reason why I want to approach this from a testing point of view is precisely so that you can get actionable insight from here. So I'm going to show you a few testing tools that you can use straight away in your job to start testing your APIs and discover issues with the APIs and start fixing them. So I'm going to show you how we do that. And the way I'm going to break down the presentation, I'm going to show you first a couple of examples of weak API implementation. We're going to discuss them. We're going to see how we would improve those implementations. Then I'm going to show you how we can use Schema thesis, which is an API testing tool, how we can use it to discover issues from the point of view of security in our APIs, and how you're going to see the feedback loop, how we run the Schema thesis, we discover some issues and we fix them. And then I'm going to show you how we do the same with Fensa, which is specifically dedicated to API security. After that, there's a missing point here in the middle. I'm going to say something about SQL injection. And you're going to see SQL injection is actually a big world here in API security. There are many different ways of doing SQL injection, different strategies. So you're gonna see that. And then I'm going to talk about API authentication and authorization, which are like the most critical elements in the API from a security point of view. The one thing that we really don't want to get wrong here. So I'm going to show you some common vulnerable implementations of this that I see in my clients, and I'm going to give you recommendations and best practices on how to navigate this area. Then we're gonna see a few more strategies for API security testing, and if we have time and we are good with time, we can see a little bit about the top 10 security vulnerabilities in APIs from OWASP. And also I want to say something about the limitations of automating API security testing. So, all right, the way I like to start my training sessions or my workshops is with a few examples of bad code. And so here's an example of a bad API implementation. This is a put endpoint. It is implemented in Flask. What you see here is what you get. And I want to open the chat here now to ask you what you see here that is wrong. Let's give it maybe 30 seconds. Let's see a few answers, and then I'll explain myself what is wrong here.
Hopefully the chat's working for everyone. If it's not, jump on the Q&A, but feel free to enter in anything. I think we fixed it a minute ago, just to check.
Yeah, write something, at least say something to make sure the chat is working. Okay, it's working.
Chat's working. Yeah, fire away, guys.
Okay. All right, that's 1 point. Okay. Okay, we're getting very good stuff here. Okay, so let's take it from here. So we got very good answers here, and we really covered most of the vulnerabilities with these answers. The first problem we are having is lack of input validation from the user. You can see here, we are grabbing the JSON payload directly here, and we are not only not validating that input, but we are not even considering whether there could be in the JSON, could be a malformed some payloads, and if that is the case, this is going to throw 500 directly to the user. So that's the first problem here. And by the way, this is a simplified example taken directly from a real code base. So this is the stuff you can find even in your code bases at work. So that's the first problem, lack of input validation. The second problem here, which is really, is the biggest problem, is this loop here, where we are iterating over the keys and values of the payloads, and we are setting them directly on the object of the database. This opens the door for what we call mass assignments. It's a type of vulnerability in which we get the payloads that the user is sending through the API, and we assign it directly to the resource representation in the database. The problem this poses is, imagine we have a user table in the database, and we have a column that tells us whether users are admin or not. And imagine this is not necessarily exposed through the database, but maybe a clever hacker figures out that this could be something that exists in the database, and they send us a payload. Now, first of all, because there is no input validation here, there is nothing preventing them from sending this property is admin and set to true, and there is nothing preventing them from setting that in the database. So users can change their user roles, or they can change properties about the user in the database if we don't have input validation, and if we assign directly everything coming in the payload to the properties of the object in the database. As others have commented, we have everything represented, implemented in the same space here. So if we think of this as a controller, we don't have any separation of concerns. The data layer is here, the business layer is here, and we should have those things in other modules so that we can test every layer of the application separately. So there is an important concept here. I didn't prepare a slide for that, but there is this concept of hexagonal or hexagonal architecture, or architecture of puts and adapters. Let me write that here. So the idea in this architecture, this way of architecting our code, is that we implement the business layer in the core of the application, and everything that is an external dependency, like the database, like the API layer, like communication with a stream or a queue, all of those things are from the business layer. And what we do is we create what we'll call a port that helps us communicate with those adapters. So the database becomes an adapter, or the part of the code that actually implements the database. Let's say SQL Alchemy, or our Django ORM, or our SQL code that is directly interacting with the database. That would be the adapter. And then we have the port that allows the business layer to communicate with the adapter in a technology agnostic way. What that allows us to do is, all right, so okay, question here, it's very important. So mass assignment. So this is one of the OWASP vulnerabilities, one of the top 10 vulnerabilities in APIs. That actually is in the 2019 list. The 2023 list, which is being discussed now, doesn't contain mass assignment, but it contains a new type of vulnerability that incorporates assignment in a way. Well, maybe we can see that later. So the advantage of hexagonal architecture, it allows us to test the business layer in a from the database or the business layer, because those become injectable dependencies of the code. So obviously that's not happening here. We have the data layer, we have the business layer, everything happening within the same namespace, and that everything is tightly coupled, so we wouldn't be able to test those things in isolation. But there is more stuff going on. We don't have, I think it was also mentioned, we don't have type validation for the ID. So a user could include here a SQL statement, and that will be passed directly to the database when we do this query here. There was also something mentioned about SQL injection. That's not necessarily the case here if we're using an ORM like SQL Alchemy. SQL Alchemy takes care of parameterizing everything as long as we are not running SQL against the database. But we will see. I'm going to show you actually how that works, and how the very few cases in which we could have a dangerous SQL injection case for APIs. And the final thing also, we don't have a validation of the outgoing payload. Whatever happens here with this transformation of the data, we're just turning it into JSON and send it back to the user. Now, this is very common, and there is an argument to say that data that comes from our database doesn't need to be validated because it comes from our own system. The argument that I have for this is it's preferable to have a zero trust approach to our data, regardless of the region. So data coming from our database, data coming from external sources, obviously, and data coming from our users, obviously. We don't want to trust any of this data. We want to have validation every time we are consuming data from any source. And there are very good reasons for this. If we are consuming data from a third-party API, we don't validate. There could be any reason why that data is corrupted or not well-formed, and we should validate that. But also, if you think about our database, there are multiple ways of getting data into our database. And some of those mechanisms, even if we have a very well-implemented API, someone can leak some corrupted data into the database or even a SQL injection statement into the database. And that is not the kind of stuff we want to throw to the user, to the consumer of this API. For that reason, we want to have validation of the data, regardless of where it's coming from. And that's what we call zero trust approach to our APIs. So this is a very bad implemented API endpoint. Something a little bit better than that is what we have in the next slide here. This is also an example from a real code base. It is a little bit better, but not quite where I want it to be. So in this case, we are consuming the JSON, still not considering the case that it could be malformed. It could be a missing bracket or something that's going to throw a 500 if we are not catching that exception here. If there is no JSON data, that's going to be a 400. So we are returning that response to the user. And at least we are also validating the payload here. We're not validating the ID, but at least we are validating the request payload. And if it isn't valid, we're responding with a 422, which is correct. And then we are doing what is actually the job of the API, what should be the job of our implementation, looking for the item in the database by ID. We are returning a 404 if the item isn't found. And in this case, we still have these dangerous assignments of the properties in the object by trusting that the user is sending correct data anytime, all the time. And also, we don't have the payload validation when we are returning this to the user, which is dangerous. Now, what I want you to do here is really we should be getting rid of the first block here from this line where we are consuming the JSON to this line where we are returning the 422. All of those things should be taken care of by a framework. So here is an example of a better implementation. In this case, it's Fast API, not because the API is necessarily better than Flask. It's because I couldn't find the time to do it in Flask, and Fast API is easy to put it together. So this is the same put endpoint on the same URL. Now we have a response model. So when we return this item, it is going to be validated and serialized appropriately. And we have type validation for the ID. In this case, it's a UUID. Now, this is another common source of issues with a lot of APIs. If we use integer IDs, which is perfectly valid for a lot of databases, is just a common way of representing IDs, and it's auto increment. Our databases take care of it. Normally, not all databases support string-based IDs like UUIDs. The only problem with integer IDs is they create a predictable surface of the API. So a user sees there is a resource with an ID 4, next 6, next one is 10. There is a pattern here. They can start doing a surface attack on the API to look for resources that don't belong to them, but they may want to try and get hold of them. So if we are using integer IDs in the database, what we should be doing is transforming those IDs into something that doesn't make sense for the user, into some sort of a string representation, a hash or something similar that doesn't expose a predictable pattern to our API consumers. That way, at least we're a little bit more protected against those attacks. Of course, people will still try to play with different strings and things like that, but at least as long as we don't have a predictable pattern, then we have some degree of protection in there. So that's good here. And we have also payload validation from the user. So that this payload here is the input the user is sending to the API, and that is going to be validated against a Pydantic model in this case. And then what we have here is the actual implementation of what will be taken care of. So if any of those things go wrong, the user will get a 400 or a 422 because data is wrong. Now, once we pass that, we do our job, which is looking for the item. If the item isn't found, we respond with a 404. And then what I like here is that we have a very explicit mapping of the properties in the object of the database and what we want to consume from this payload. Because it could be the case that this payload is not entirely securely designed. Maybe we've leaked this admin property in this payload or something similar, and the user is still sending a valid payload to the server, but we don't want to grab that property, especially in this case. So we want to be, as far as possible, we want to have a very explicit mapping between the objects, the properties we want to update, and the information that the user is sending to the server. So once we've done that, we save the item into the database and we return the item, and FastAPI takes care of validating and serializing that by using this return response model. So that's how I want you to build your APIs, validating URL parameters, both path parameters and query parameters, validating response payloads and input payloads. Now, another example here of a really badly implemented endpoint. This is a collections endpoint. So in APIs, we distinguish between collections endpoints, which represent the collection of items, and singleton endpoints, which represent a specific resource. So this is a collections endpoint with a get. So this is reading the list of items from the database. And we are doing things also a little bit badly. To open the chat again and ask you 30 seconds to see. Okay, good one. SQL injections. What else is wrong here? There are a few more mistakes. We've got SQL injections. Some of these errors are the same we saw in the previous example. Lack of exactly. Lack of we are not validating those values. Exactly, and expecting that those values actually exist, right? So the first error here is, you see the way we are accessing this is a keyword access. We're not even doing a soft access with the get method on the dictionary. We're expecting those values to exist. If they don't exist, it's going to throw a 500 to the user. And the second problem is we are not validating them. So it's not helpful to have a limit and an offset if a user is going to set the limits, the offset, let's say, to 1 million value. It's requesting 1 million items from the database. It's still going to blow up the database. So that's why I put here, blow your server. Because if those values are not correctly set, we're going to put a lot of strain on the database. So first thing we want to make sure is that we have default values here. And you can do that with Flask, and you can do that with FastAPI and Django. Any framework has a way of doing this. And actually, something I want to say about Flask, the most common mistake I see in a lot of organizations is building APIs with Flask with like bare Flask, without using a proper API framework. So something like Flask Small REST. Let me write that here. So Flask Small REST. And there are some other good frameworks to APIs with Flask. The good thing of using these frameworks is that they take care of data validation. You just define your models. You hook up those models for payload validation, either incoming or outgoing validation, the same for query parameters, and they're going to take care of validating the data and responding to the user with the right status codes if the data is invalid. Just one thing about Flask Small REST is it doesn't have a built-in way of validating outgoing payloads. So you're going to have to do that yourself. In my book, I explain how to do it. And if you have any questions about that, ping me, because I can explain you. It's very easy to do. So we have lack of input validation here. We don't have small REST is here. An easy name. So one question. No, I'm not writing anything. I'm just showing the yes, in the chat. Can I give what I write in the chat? Can you see what I write in the chat? If I can answer, no? Oh. That's not good.
Ooh,
I was putting a lot of information. I was putting a lot of data.
Let me have a look at what's gone on here. It should allow everyone. Right, let me have a look.
Oh, wait. Yeah, my settings were. I
Right.
was going between me and the panelist.
Drop,
I guess,
I'll go up, Jose, and copy and paste those to everyone
yeah.
so that Jose
Okay.
can,
If you can
we
put
can carry
also
on.
the discount codes and everything and
Yes,
the
I'll sort
URLs.
all that
Yeah,
out
okay,
now.
thank you. Yeah, sorry about that. As the marvel of Zoom sometimes. So yeah, so you will see ask small rest, and also you will see the mass assignment stuff that I wrote before. So what I want you to do is to use frameworks like that to have built-in validation for the data. And of course, the other problem we are having here is the string interpolation in the query. So that can open the door for different forms of SQL injection. So instead of that, the other piece of code, right? So no access rights. So we are not checking whether the user has access to these things or not. So here's a recipe of pagination for your APIs. Again, it's done in Fast API. It's just because I had the examples already prepared in Fast API. And this is a recipe for pagination that you can implement it like this and inject it to any collections endpoint if you have a Fast API application. So the way you see here, we have a products endpoint, and we have the pagination parameter here, which is set to an annotation that tells us that there is a return value, which is a pagination type. And the way we resolve that is with a pagination parameters function that takes care of validating the parameters and returning the right type. So what we have is already contains the parameters. In this case, there are different patterns for API pagination. First of all, there is what we might call cursor-based pagination, which is what you see, for example, on Twitter or LinkedIn. So you go to the page and you just scroll and scroll and scroll. You don't select how many posts you're going to see per page or which page of the post you're going to see. So that's cursor-based pagination. This is explicit pagination. So in this case, we ask the user how many items they want to see per page and which page they want to see, and also the sorting order of the items. So something like this, it contains the minimum value greater than or equal to. It contains the maximum value of the parameter lower than or equal to, and it contains default values as well. And the same for the order parameter. It can be, it's an enumeration, so it can be ascending or descending and nothing else. And if the user sends us different parameters, then it's going to be rejected. Now, one question here about MSG specs versus pedantic. I'm not familiar with MSG specs. So all I can say is that pedantic is really cool, really good. It's and it has, you know, the amazing thing about pedantic is it is very flexible. It allows you to define a lot of custom validation rules, but it also really has like validation for any type of data you can imagine. So specific types of integers, I think even for multiples and things like that. So it's a really powerful data validation library, and you can use it in a strict mode, which means in something like this, for example, here, this is like soft mode. At the, in pedantic version 2, this will be strict. But what's going to happen here in version 1 of pedantic, if somebody sends a string as a string that represents a number, that will pass. But in pedantic version 2, it's going to be strict. An integer has to be an integer and a string has to be a string, not something that can be casted into the other type. All right, so these were the examples of bad implementations and how we can correct them. Now let's move on to the testing. So the first kind of testing I want to show you here is with the Schema thesis. So Schema thesis is an API tool. What it does is it validates that the API is correctly implemented. And it is a kind of API testing tool that we call fuzzers. Fuzzy is like an API fuzzing or API fuzzer. So as the name suggests, there is a randomizing component here in the way it is testing the API. The basic idea is we feed an API specification into Schema thesis, and then Schema thesis looks at the spec. It understands what are the requirements of the API, and based on that, it creates a ton of valid and invalid test cases, sends them to the API, And depending on how the API responds, because the schema thesis know what is the expected response, it tells us whether the API is correctly implemented or not. Now, like I say, there is a randomizing component here, so it's not going to test absolutely all cases. It's going to have a sufficiently large coverage to give us confidence that implementation is good enough, but it is our responsibility as the API developers to make sure that we cover any special edge cases or things like that. A few more details here. The strategy API schema thesis use is known as property-based testing. Basically, the idea is we define the conditions to generate a test, and that is done with a library called schema thesis in the case of Python. And based on those properties or on those conditions, schema thesis generates test cases. And then based on the properties of the test case, we decide whether the test case should pass or fail. So it really works very well with the schema-based testers, like something like a schema, like APIs, whether it is a REST or a GraphQL API, it works very well with this case. So schema thesis looks like this. It's a command line tool. What we do is we run it from the command line. We give it the path to the file and to the base URL of our server, and it tells us whether there are any errors. One thing I want you to notice here, and I'm going to run the tool also against a real code base. This is an image. So there is some nesting in those tests. So these get orders, post orders, and then some nested tests here. Those are tests based on something we call open API links, which is this. So this is an open API link. Open API links is a syntax in the Open API specification that allows us to describe the relationships between different endpoints. So what we're doing here is we say there is a post-cuts endpoint in our API that returns a payload, has a response which is 201. That contains a payload with a response body that contains an ID, and that's the ID of the resource we are creating. And what we say is this ID can be replaced for the cut ID parameter of the resource URL implemented in the pay operation ID. So basically, it allows us to say that this post endpoint creates a resource that we can use from other URLs, and then the schema thesis can use this information to make sure we can actually do those things in those resources if they are created. So let me show you how we run schema thesis. I'm going to do it with the PyJobs API, which is the API I'm using in the online course I mentioned before. It's not the most complex API in the world, but it's a little bit feature rich. So let's not go through that to waste the time on that. But what I'm going to do, I'm going to run schema thesis now, and you're going to see it gives us some errors. I'm going to show you the feedback we get and how we can interpret that feedback and do the code fixes. If I can find the command from before. So it looks like this. Schema thesis run the OpenAPI specification file, the base URL of our server, and also here we are saying to do all kinds of checks. First thing I need to do is to run the server, actually. So this is a fast API application. So we say ubicon, PyJobs, server, reload. And so that's the server running. Now we're going to run schema thesis against that. So this is going to do the basic against the API. It's only going to check that we don't have 500 errors. So let's see what happens. So it's already telling us there are some errors in the get skills endpoint and the get locations endpoint. And also we have an error in get candidates. And then it's going to tell us a summary of the errors, why they happened, and we can go to the code and fix them. Okay, so it's run. This 23 are the endpoints, and these are the test cases it's created. It's around 1,000 test cases. Now, what schema thesis is doing here, this again something I see in a lot of API implementations out there. How do we test an API really? the things we need to take into account what are the valid payloads, and we need to make sure that the API is rejecting any kind of invalid payload. If we were to write all of those test cases by hand, we would take, I don't know, years writing those test cases, because it can be in the order of thousands, like you see here. So instead of doing that, what I encourage you to do, of course, write your unit tests, and especially for those edge cases that are important to consider. But for everything else, let the schema thesis test the API. It's only going to look at the API layer. It's not going to the business layer or the logic of your application. It cannot do that because it only looks at the OpenAPI specification file. But let schema thesis take care of that. Take that heavy lifting of making sure the API only works with the right data. And then you can focus on building, the API, the business layer, and everything else. So another wording here also, if you're running a schema thesis, it's running against the actual API. So if you create resources, it's going to be in the database. So don't run it against production. Don't run it against if you have concerns that it could pollute a dev or a staging database. Don't run it in those environments. Run it against a local database or something similar. And so the feedback we get is, for example, here, this the get candidates endpoint. So it's telling us that there is we get the stack trace also. So if we look into the error here, it says that the candidate status enumeration doesn't have a valid value here. So I know already what it is, so I'm going to make the fix very quickly. But if you were this against a database and you get new errors, then you just follow the trace and you see where you just look for where the error could be. So in this case, we're going to go to list candidates, which is this endpoint. And then I know that there is something here is that we are not passing the actual string representation of this enumeration. We are passing the enumeration, and SQL Alchemy doesn't process enumerations like that. So that's the first fix. Then we go up. And also to confirm, you can see well the terminal, right? The size is good for, you don't have any issues reading the output. Okay. So the second error we have here is get locations. And what it's telling us is, this is very interesting. This is why I like to use schema thesis in cases like this. So it's telling us is using a very large integer. So this integer here for the page parameter. So it's obviously not only a problem for SQLite, but it's telling us something is a little bit off in the design. So if we go to the OpenAPI specification here, and I look for parameter page, so name page. So I commented out these value, this value here just to make the test case. So if I enable this, a schema thesis will not give us values higher than this, but we also need to make sure that in our API implementation, when we have the pagination parameters, they are correctly defined with minimum and maximum values. So if we go, we have page. So here we want to make sure we have a default value, we have a greater or equal to, and also we want to have lower or equal to, let's say 500,000. So this, no, sorry, per page, we want to say per page, let's say maximum 100. And for the pages, let's say we have a maximum of 500,000 pages. I don't think it's really worth having users navigating so many pages. So less than or equal to 500,000, something like that. So those, now we've taken care of those errors. And let's see if I have another one here, which is skills. So get the skills. We have an error here with the type. So it's telling us in the response, there is a skills property that is an array, and it contains an object. It contains a name property, which is not an integer. Now that's a little bit off. The name of a skill should be a string. So let's see what's going on in the schemas file. And we look for class skill, I think it's the one. So you see I'm setting this name to a string. It's not really, shouldn't be that. It should be shouldn't be an integer, it should be a string because it's the name of the skill. One question here. All right, so a couple of questions. The first one, how I generated the OpenAPI specification. I did it in this case, actually, to be fair, I did it with a combination of ChatGPT and myself. So it's a very large specification, and I didn't want to write everything myself, but I did know what I want the specification to look like. So I gave the requirements to ChatGPT. Now ChatGPT is really not very good with many things. It was giving me a lot of garbage, but that's something you can correct. You can, especially when the output gets very large, it gets more inaccurate. So then you go to specific sections of the API and say, give me the right schema for this object with these requirements. And then you just tune it yourself with the maximum values, the minimum values, enumerations, and so on. And so that's how I did. And then actually a lot of the that you are seeing here in this iteration are actual mistakes that I made in the design and the implementation. So when I was recording the course and I come to the testing API testing section, and I say, my goodness, so many errors. What did I do here? That tells you actually that it's very easy to make mistakes with APIs, with the design and implementation. So it's really useful to run a schema thesis at any point of your design or implementation iterations, because it's going to give you really valuable feedback on how the APIs look, what the API is looking like. So I encourage you to do that. If you go tomorrow to your work, you have an API specification, you have the implementation, run a schema thesis, but like I said, against a local database or something similar, because you're going to end up maybe with a million items in the database that maybe you don't want to have. Another question here. When should we have the OpenAPI specification file? My recommendation is at the beginning. So the idea is what I evangelize, what I encourage everyone to do is, before we build the APIs, we design them. And this is very important so that we can have the right expectations on the API, so that we can build them correctly, but also that the consumer of the API, whether that is, let's say, a front-end application or another microservice, or perhaps a third-party integration, we have a client consuming our API, so that they know what the API is going to look like. So we agree that at the beginning with a design, and in the ideal world, we document that also with a standard, something like the OpenAPI specification. And then we follow the rules. We implement the server following that. And that's going to it's going to be so useful in our iterations, because there are a lot of details that don't come to mind when you're just building the API directly from code. And they're going to become very obvious when we see the specification. We can run a mock server. We can start playing around with it before we have any actual server code. And also it serves as a validation tool. So like you see here, we feed it into schema thesis, and it takes care of running all the tests that are necessary against the server. Now, another thing here, this doesn't prevent you from writing actual code from the very beginning. If you want to do iterations on your API directly from the code, that's perfectly fine. The only thing I'm asking you to do is, at some point, have a design established and let the schema thesis take care of the rest by validating your implementation, and let also your consumers of the API run mock servers and all the other useful tools to work with the API. So that's my recommendation. So, okay. We've done these fixes. Let's see if you have any more questions, keep putting. I'm reading that as well. And okay, so those are the errors we had before. Let's run the test again with those fixes and see what happens now. And I have to apologize to Sam, because I think I told him this would be something between 20 and 40 minutes, and I think it's already over 45 minutes. So maybe we're gonna have to cut it short at some point and continue another day. Okay, so you can see now all the tests are passing. The next step here would be to run, there's another flag here we can use in Schema thesis. We say, like I said, the basic test is only going to check for 500 errors in the server. So just make sure that the server isn't breaking unexpectedly. If we want to run all the checks, so let the Schema thesis check our headers, conformance with the schemas and so on. Then we run like this check all, and that's going to run all the checks against the API. Now, before I continue, Sam, how much time do you think we have left?
However long we all want, I'm pretty free to continue on myself.
Yeah.
And if obviously it's going to be how long people obviously need to jump off, we record this so it can be carried on. So probably the best way to go is to go until you see fit, Jose, and then we can always continue on should we need to at another point.
Okay, so I'm gonna run just this test, and then I'm gonna show you a little bit about Fencer. I'm not gonna go into much detail into that, and then say a few words about authentication and authorization, and then we do another webinar to deep dive into the issues. So we run this test now with no check. Let me see. Checks, because in plural. And so now it's got another error in the get jobs endpoint, because now it's checking for schema conformance and all of those things.
To answer that, yes, we will get that sorted, Oliver. It is at the top, but obviously with the technology issues and me setting the chat function up wrong for Jose, I have not managed to type that out just yet. But I'll make sure that that is sent out to everyone as well, or I'll type it in here. I'll get that sorted.
Okay, thank you. So okay, now what you can see here, here are the checks, right? So the first one, making sure that it's not raising a 500. Second one is the status code conformance. So if there is any status code that isn't documented in the API specification, it's going to tell you that. If we are returning an unexpected status code, it's also going to tell you that. The content type as well. So making sure, very important actually, if we are running, if we run the API in debug mode, often we get is an HTML with a stack trace and everything. So make sure that doesn't happen, especially in production, and checking the headers and the schema. And here's where it failed. So let's see what we have. So it says in the get jobs endpoint, the problem is we have these return value pages. So the payload looks like we say, give me the list of jobs, and also tell me how many pages there are. The minimum value should be 1. So here is saying pages 0, that is less than 1. So we're going to fix that. So we go to the API, and I know what I need to look for is we are using this method here, the sailing method. What we're doing is we are taking the count of items from the database, and we are dividing that by the number of items per page. That gives us the number of the rounded number of items to the top. But if items is 0, then the value is going to be 0. So what you're going to say here is this or 1, and then we're going to look for the next sailing and say here or 1, and here is the same or 1, and here is the same or 1, and here is the same or 1, and that's all. So that's going to ensure if we have 0, then at least the page is like 1. Is that there are no pages really, but that's the requirement in the specification. So we run the test suite now. Is this a question to report? Yes, I have a repository for this, and actually let me see if I can. So if I go to my GitHub, there is JWT workshop, this one. So this contains a similar implementation to what I'm showing you now. And so that contains all the code. It contains the specification, it contains the implementation, and it contains a lot of tips about using, this is only for authorization. So you have examples of using, doing JWT validation with all the main Python libraries. So PyJWT, JW Crypto, and Jose, and you have examples for validating and also for generating the tokens. And also you have an example of middleware in Fast API and things like that. So it's quite useful. So let's run the test again and see what happens.
Everyone should now have access to the online course and the book pages. Obviously, the discount codes I put in the chat earlier. I hope they all should now be working for everyone.
Thank you. Okay, so we got the previous failing test passing, so it should be just working fine now. And another thing, actually, you're going to see with the schema thesis, like I said, there is a randomizing component. So it's like the test strategy is going to be different every time. So you might encounter new errors every time you run the test suite, and that's perfectly fine. The idea is, I mean, like you see here, it's over 2,200 test cases for each of these checks. So every time you might encounter different errors, but the idea is the volume of test cases is sufficiently large to give you enough confidence on the implementation. So this is the example with the schema thesis. And just to mention again, if you have API specifications in your APIs, please make sure that you use also OpenAPI links. It's so useful. OpenAPI schema thesis is going to make magic with that. To validate that you can perform all those operations with the resources created through those endpoints.
Just to very quickly answer the question, the recording will be sent out via both Jose and Amicus's LinkedIn. So we'll post it all online with the links to all the recordings. Should people need to jump off, but yeah, sorry for interrupting.
Yeah, no, it's a good point. And also, I'm gonna put all of these resources on LinkedIn. So if you connect with me or follow me, you will see when I post these things in the coming days as well. So that is schema thesis and OpenAPI links. And now I just want to show you a brief example of Fensa. So Fensa is this tool that I'm building on GitHub. It's open source, and the idea is to build an open source API, automated API security testing tool. And the reason I wanted to do this is because a lot of the API testing tooling is vendor specific, and you have to pay for that. So you have to go to specific API security companies like Walam or No Name Security, one of those, and you have to pay them, and I don't know how much because they don't have public prices. So the idea is I work with a lot of the startups, and I know how tight the budget can be sometimes to work with software and to build software. So thinking of those companies, I'm building this tool. It's in the beginnings now. So if you have suggestions or you want to make a contribution, I very much welcome that. And if you're looking to make your first contribution to open source, I'm very happy to sit down with you and go through the steps to make a contribution to Fensa. So it's available here on GitHub. I'll put the URL also here. And I'm going to show you what it looks like when we run it. The idea is it's going to check the stage in which I have it now is looking at the OWASP vulnerabilities. I have 2 of them implemented. It's going to run them against the API and see if we have any vulnerability in the implementation. So we do it Fensa run. You give it the path to the specification file, the base URL, and it runs like this, the test cases. So 500 cases in this case. It hasn't found anything vulnerable with a SQL injection, nothing with unauthorized access. Unauthorized access is simply checking that protected endpoints cannot be accessed with an unprotected without the token. And I'm going to include tests also to see there's a common vulnerability with JSON Web Tokens, which is when we set the algorithm, the signing algorithm to none, then that means there is no signature to validate. It's a very common vulnerability. Even Auth0 was a victim of that. So I'm going to include tests like that to make sure we don't have those vulnerabilities in the API. But also I want to say, if you're working with Python and you use any of these libraries that I have in the repo that I shared, PyJWT, JWCrypto, or Python Pose, they don't allow you to, they're secure by design, so they don't allow you to set the algorithm property to none. So you're protected in that sense. So that is running with Fensa. Again, I don't recommend you to run any of these tools against production because things can go really wrong. And if you do it in a dev or a staging environment, make sure you talk to your colleagues and they are aware that something can go fantastic. And ideally, it's with a local database. That's what I recommend you to do. So, do you think we leave it here or we continue a little bit more, Sam?
If you think you've come to a point where we can, I suppose, pick up later on down the line in a part 2, yeah, I'm more than happy we can get that booked in for a couple of weeks down the line, if that sounds good.
I think that sounds good. Yeah, we've seen examples of bad implementation, how to overcome them, and we've seen how come we do some testing with the Schema thesis and Fensa. The next thing I wanted to show you is an actual example of SQL injection, which we can do in the next session, and talk about authorization versus authentication, vulnerabilities in this area, and maybe we can cover also the OWASP vulnerabilities and see how we can test against them. And that's a good hour we spent today.
Fantastic. Well, obviously, we can get that booked in. Everyone that's obviously being or joined in and obviously contributed and put in the chat, really appreciate it. We'll get that booked in for maybe a couple of weeks' time for everyone to digest and put into practice what you recommended so far, and we can get started on that. Obviously, we'll all the links are in the chat now for everyone. If you need anything or you want me to put you in contact with Jose, drop me a message as well. Really appreciate everyone joining. Obviously, thank you very much, Jose, for coming along today, and I look forward very much to the next talk.
Awesome. Do you want to leave a few minutes if someone has a question?
Of course.
Here?
Yeah. Feel free. Obviously, if anyone has any questions, last minute questions for Jose, please fire away. I won't just end the webinar just yet.
Okay, and let me actually go to the last slide here. I have like 60 slides, so it would be probably too much to do in one go. But the last one here, this is the details of the giveaway that I was mentioning at the beginning. Remember, 3 ebook copies and 15 signups for the course. Grab the URL, put your details, and I'll announce the winners tomorrow or after tomorrow as soon as I can.
Fantastic stuff. Has anyone got any final questions? Obviously, feel free to reach out to Jose as well on his LinkedIn for whether that be any consulting you need, any consulting needs you might have, or if you want to introduce into your business, please feel free to do so.
Please.
or just any questions in general. Obviously, if you need any advice, if anyone is looking as well for any work, feel free to reach out to myself or Amicus. Obviously, we cover both Python, sort of that's my remit, but we have a range of different teams here as well for anyone that might be interested. But all of this will be obviously posted in the next 24 hours, so keep an eye on it, and we'll also announce when the next session is going to be. But it looks like I don't think we've got any questions coming in at the moment. So what we'll do is we'll end that there. I really appreciate everyone's time today. It's been great having you, Jose. Unless you've got any closing statements quickly.
Yes. Just to say, I would like to say, if you have any questions that you come up with in the coming days or something, feel free to reach out to me, or feel free to raise those questions in the next session. Hopefully we'll have a continuation here, because there are a lot of things I want to tell you about authorization, authentication, and those things. Make sure you enter the competition, because there's a lot of stuff we're giving away, and maybe we do another one in the next session. And thank you for coming, and hope to see you in the next one.
Brilliant stuff. Cheers, guys. Have a great evening. Have a great week.
Thank you. See you.